TTL Computer II. Today we're going to be taking a look at our ALU circuit design as well as our PCB design. And we're already looking at our first sheet in our schematic. And this schematic is virtually identical to our digital simulation design. The major difference here is the addition of our resistor networks that we've added for impedance matching uh, to our data bus. And besides that, I've done some of the typical changes that I've done in the other cards to improve trace routing, and I've reversed the directions of most of the bus signals. So this was 0 to 7 before. I switched that to 7 to 0. Same thing here. Switched from A0 to 7 to A7 to 0. And the same thing with the data bus signals were reversed as well. And so that's one of the changes I made, minor changes from our digital simulation. And the other change is I uh, reordered the output signals on our GAL chip. And the reason why I did that was to match the input signals to the 74 LS181s, the ALU chips. So uh, again, to eliminate crossover. So these are just going to be, straight wires in, right? We have S1, S0, CN, and M. So those have been reordered to match the, physical pin ordering of the ALU chips themselves. Okay, so those are the active elements on our schematic, and then the passive elements, again, pretty much the same as the other cards. We have our decoupling power capacitors. We have, or rather, the decoupling power capacitors, the bypass capacitors for each of our ICs. We have our power indicator, and we have our card edge connector. And again, we've standardized here for our clock signal inputs. And then we generally have uh, the data signals up top. So we have A0 to A7 here. We have B0 to B6, right? And that's both the A and the B arguments to the ALU. And then we have D0 through D7, which is our data bus. And then we have our output flag signals, the negative signal, the carry signal, and the zero flag signal are there on the card edge. And then we have our input signals to the ALU. We have the ALU control bits 0, 0, 1, and 2. We have the flag input signal. And then finally, we have the U clock signal. Okay, so that's our schematics diagram. And now we can take a look at the PCB design. And our PCB design is again similar to our other PCB designs. We generally have our input signals to the left and the output going signals to the right. So we can see here that we have um, this is argument A to the ALU, argument B, and then our control signals, right? So they're coming in from the card edge, wrapping around to the top, and then they'll be pulled down to the ALU chips. And then here is our output data bus on the card coming down to our 74 245 uh, bus driver chip through the resistor network. So that's kind of our top of our board routing, and we can see now here the bottom of the board routing, right? We have our signals coming down, our input signals coming down to the ALUs. Then we have our output signals from the ALUs coming down to the data bus. And this is our flags chip here. And this is our zero flag uh, comparator chip, and then the the output from the flags comes to another bus driver 245, and that's brought out to the card edge connector. Okay, so nothing too particular about this board design. It's pretty busy as far as going with the routing, the trace routing goes, um, but not too many surprises and no real hardships. It's just takes quite some time to do the routing, and we're obviously doing that all manually at this point. Okay, so we can take a look at our 3D model now for our card. Right, we can see that we have our power indicator. We have all the silk screen markings for all the chip identifications are present. Here's our two ALU chips. Here is our GAL chip that we implemented to simplify and remove those 7 combinatorial ICs. And that's it. Now here I used a 33 ohm resistor network. Said these resistor networks are a little bit pricey, I have kind of a limited supply of those. So if we're not doing, a full eight bits out, I just use individual 33 ohm resistors there just to save on using the resistor network. Okay. And then we can check this out again. Get our card edge connector, right? Just to make sure we have a little bit of a gap there between the card and the board, so the tolerance isn't too tight. But that's it. So that looks good. And that's our card. Nothing too spectacular or different from this card from the others. Again, it's the same board outline, 200 millimeters by 150 millimeters. Okay, so that's our ALU card. I'm going to do final check on that this tomorrow and get this off to fabrication. And that brings us to our last card. We have one final card to do, if you can believe that, which is going to be our control unit card. And that will complete our card build out and leave just one major component left, which is going to be the backplane or the motherboard. So that's it for today. Until next time, thanks for watching.